This is part 3 of graphing sine and cosine functions. Part 1, we identified all the major components. Part 2, we started graphing some transformations, and here we are in part 3. We're going to do 3 examples, and I'm going to try to speed it up a little bit so we can get these in and make the video a reasonable length of time. Alright, so first step, we identify the major components, the period, the amplitude, the step, and the starting theta values. So the period for this one is no change. The b value is an implied 1 right here, so it's 2 pi over b. So in this case it's 2 pi over 1, so that means it's 2 pi. So the period, same as the parent, equals 2 pi. That means the step is the same as our parent function, so it would be pi over 2. So no change there. Amplitude, no change from the parent function actually either. So the amplitude is this number here. It's an implied 1, so amplitude is 1, just like the parent function. So our change here is going to be the starting theta value because we have a horizontal transformation. So instead of 0, this thing is moved left by pi over 6. So that means our starting theta value will be pi over 6. Now, this is a case because our, we need to make that negative pi over 6. So our starting theta is negative pi over 6. So this is where we need to make a common denominator between our step and our starting theta value. If you don't, it's going to be a mess to mess with the fractions. So we want this to be in terms of a pi over 6. So I need to multiply the numerator and denominator by 3 to make a 6 in the denominator. So that would be the same thing as 3 pi over 6. So now common denominator, 6 here, and you'll see that it'll make it a little easier, and we're going to end up changing the scale of this graph later. So next thing we do is make our parent table for cosine theta, and we'll put our theta here and y values next to it. So 0, pi over 2, you should have this memorized by now, pi, 3 pi over 2, and 2 pi. And then it's, for cosine, it's 1, 0, negative 1, 0, 1. Now make the changes. So this would be cosine of theta plus pi over 6. Remember, it's left and right opposite of the sine, so that's why it's left, not right. Theta and y values. So the starting theta value is negative pi over 6, so I'm changing all of these x values, so it'll be negative pi over 6, and then we're stepping by 3 pi over 6. So if we're at negative 1 pi over 6, add 3 to the negative 1. Negative 1 plus 3 is 2, so 2 pi over 6 will reduce later. Then 3 more would be 2 plus 3 is 5 pi over 6. Then 3 more, 5 plus 3, 8, so 8 pi over 6. That's 1, 2, 3, 4 points. We need one more point to complete a full period of the graph. So add 3 to 8. 8 plus 3 is 11, so 11 pi over 6. Now we can fill in our y values. They don't change, so we just copy them down. 1, 0, negative 1, 0, and 1. Make sure it's in order. The whole process we've set up, it requires you to go in order, and we're stepping up by our step. 3 pi over 6, 3 pi over 6, 3 pi over 6, 3 pi over 6. Alright, so let's change the layout of our graph over here. Let's change the scale of the theta axis. So I'm going to make each one of these a pi over 6. Each one of these vertical lines will be a pi over 6. So I'm going to make this, I'm just going to get rid of all these. Probably should erase. I think that'll be better. And we're just going to say that each one of these is pi over 6. There we go. And we'll label it, we'll come back and label it in a minute. So this is negative pi over 6. This vertical line right here is negative pi over 6. So put in our horizontal lines just to mark our max and min, just to make it easy to see. And remember, this is not actually part of the graph, that's just there to help us. So we'd be at 1, and then at 2 pi over 6, so 1 pi over 6, 2 pi over 6 right here, we're at 0, and then 3 more of these lines, 1, 2, 3 pi over 6, we would be at -1. So let's just go through this. This is 2 pi over 6 right here. This is 3 more 5 pi over 6 right here. Okay, and then 3 more grid lines. 1, 2, 3. We're back to the middle. 3 more. We're at the max. 1, 2, 3. We're at the max. And then 1, 2. What would be 3 about right here? We're back to the middle. So graph looks like this. And we'll label this. So this is 2 pi over 6. Well, actually, let's go over here and reduce this. So that would be pi over 3. And this would be 4 pi over 3. And we'll leave 11 pi over 6 alone. So pi over 3 right here, label it. And then 5 pi over 6 right here. And then 4 pi over 3, reduced. And then 11 pi over 6 over here. So we have scaled our graph, and let's make sure that it works out. So 2 pi over 6, 3, 4, 5 pi over 6, 6, 7, 8 pi over 6, 9, 10, 11 pi over 6, 12, 13, 14 pi over 6, check. So everything works out. We're allowed to scale it the way we need to make it work for our table. So that's a more difficult example because you do have that change in your step, and that makes it a little more difficult. So that's it for example 5 here. One more note on this. So if you notice, we went from negative pi over 6 to 11 pi over 6. So total, we traveled 12 pi over 6, 12 pi over 6. And that equals, if you reduce it, 2 pi. And that's what we want. We want to graph one full period. All right, number 7, 1 plus sine theta. We have a vertical transformation here, and that's it. Now, a lot of students get confused. 1 plus sine theta is the same thing as this, sine theta plus 1. It doesn't matter if the plus 1's in front or behind. It's still a vertical movement up 1. So let's fill everything out. Everything is going to be the same as the parent function. So period is going to be 2 pi, no change. The b value here is still an implied 1 right there. So that means the step is the same as the parent function, still stepping up, pi over 2. The amplitude, no change. It's still 1, same as the parent function. There's an implied multiplier of 1 right there, still 1 for the amplitude. And then we're not horizontally shifting this thing at all, so start will still be 0. So cosine theta, graph theta and y. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. For cosine, start with whoops. This is sine, isn't it? Yes, it is. So let's change that. Got used to doing cosine. So sine theta. Sine is the y value on the unit circle. So it's 0, 1, 0, -1, 0. Now the transformed 1 plus sine theta. So easy enough. All we have to do is leave the theta values alone. No change there. And add 1 to the y values. So still 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now add 1 to these. So it's 1, 2, 1, 0, 1. I just added 1 to all of those values. That's it. We're shifting the whole wave, the whole sine graph up by 1. So the minimum is down here at 0. Put my horizontal there in, and then the max is up here at 2. So we're going between those two values. And we'll use green here to graph it. So we have 0, 1. This is actually the middle. And then pi over 2, 2, max. At pi, we're at the middle, which is 1. And then minimum. And then middle. And then max. And then middle. And then we would be down here at the min, out here somewhere. So sketch this graph in like this. And we'll call that good for this one. We've completely graphed that. So we took the whole sine wave and we just moved it up 1. So the middle, The middle moved up 1, the max moved up 1, the min moved up 1. The whole thing just shifted up. All right, last one here, 4 sine 4 theta. So we've got a lot going on here. We need to identify the major components. Period is 2 pi over b, 2 pi over b. So the b value for us, it's always sandwiched in between either sine or cosine and your theta value. So that would be 4. So 2 pi over 4 reduces to pi over 2. And that means the step is going to change. So the step is the period divided by 4. So if I'm going to do this off to the side and then erase it. So pi over 2 divided by 4 over 1, flip and multiply. So you get this, pi over 2 times 1/4. So pi over 8. So the step is going to be pi over 8. Pi over 8 for the step. The amplitude is also changing from the parent function. It's the multiplier in the very, very front. So instead of 1, amplitude is going to be 4. The starting theta value does not change because there's no horizontal shift left and right here inside the parentheses. So start is going to be equal to 0 here. So now we can make our table. So the original is sine theta, and theta, and our y values. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then it's the y value on the unit circle, so 0, 1, 0, negative 1, 0. Now the changes, so this would be 4 sine of 4 theta. So make our table here for our transform function. So the starting value isn't changing, so 0 there. And then we need to realize that we're stepping pi over 8, and we'll reduce later. I recommend you do that. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 1, 2, 3, 4, 5 total points, so that's enough to get a full period. And now our y values. So we're multiplying the y's by 4 because of this number right here. So our peaks are going to be at 4, our mins, our valleys are going to be at negative 4. So 0, 4, 0, negative 4, and 0. Now let's go in and reduce these. So this one will reduce to, use another color here, this one will reduce to pi over 4, and this one will reduce to pi over 2. So let's change the scale. Let's make each one of these a pi over 8. That's what I'm going to choose to do here. So erase these, and then we'll come back in later and label them. But we're going to use pi over 8 for each one of these, for each vertical line. So let's put in our vertical max at 4. Remember, this is not part of the graph. It just helps us graph it. So we've got a horizontal at 4 and negative 4. We use green to graph. So we have 0, 0 here. And then pi over 8, 4. We said each one of these vertical grid lines is going to be a pi over 8. And then at the middle at 2 pi over 8, min 3 pi over 8. 4 pi over 8 will be the middle again, 5 pi over 8 max, and so forth. So each one of these lines is a step the way we are scaling our graph. So we just go from min, max, middle, max, middle, min. We use the pattern and graph this thing in here. So we change the amplitude and we change the period of the graph. So the period is faster. It completes a cycle in a shorter amount of theta travel. And the amplitude is also vertically stretched. So its distance from max to middle is 4, and also from middle to min is 4. So the overall height would be twice that, or 8. Okay, let's label it. We said each one of these was a pi over 8, so this would be 1 pi over 8, and 2, 3, 4 pi over 8, which is pi over 2, right here at 0, we're in the middle, and then 4, 5, 6, 7, 8 pi over 8 would be at pi, where we should be in the middle there again. So that is it for this video. That's it for this problem, and that's it for the video. All right, one last thing. So notice the period is pi over 2. So we're going up through the middle right here at 0, makes it easy to measure, and then we're going back up through 0 again right here at pi over 2. So that distance is pi over 2. That's another check that you can do to make sure that you graphed it correctly. All right, that is definitely it for this video.